Воскресенья день просветится людям, Пасха Господня Пасха, во смерти Бог жизни, и от земли к небеси Христос, Бог нас приведет победною Твою сия.
A shortcut to valid syllogisms. A companion to Aristotle's Prior Analytics, chapters 4 through 7. As I've discussed in my other video on Prior Analytics, chapters 4 through 7, there are three figures of syllogism. Here we're going to be focusing on assertoric categorical syllogisms. If you want to know what that is, go to the other video on Prior Analytics 4 through 7. Now, the three figures of syllogism are just based on the configuration of the terms in the syllogism. So, putting the major premise first and the minor premise second, and the conclusion last, we have three different ways of configuring the terms within a syllogism. In the first way, the middle term is first the subject of one premise and then the predicate of the minor premise. In the second figure, the middle term is the predicate of both premises. And in the third figure, the middle term is the subject of both premises. In all three figures, there are three terms. The middle term occurs twice in the premises and not at all in the conclusion, whereas the subject term of the conclusion and the predicate term of the conclusion are called the minor term and the major term respectively. The minor term appears once in the premises, in the minor premise, and the major term appears once in the premises as well, namely in the major premise. Aristotle gives different definitions of middle term, major term, and minor term for all three figures. But modern conventions specify that the middle term is the term not found in the conclusion, but found twice in the premises. Whereas the major term is the term that is the predicate of the conclusion. It's found in a premise called the major premise, precisely because it includes the major term. And the minor term is the term that is the subject of the conclusion, and it's also found in the minor premise. The minor premise is called that because it includes the minor term as well as the middle term. The premises are called major or minor based on whether or not they contain the major or the minor term. Now, Aristotle often gives an abbreviated version of each of these figures. A, B, C for the first figure, M and O for the second figure, and P, R, S for the third figure. In this video, we could largely ignore the purpose why Aristotle gives this threefold division. But you'll notice that for the first figure, the middle term appears in the middle. For the second figure, the middle term appears first. And for the third figure, the middle term appears last. But again, we could largely overlook this convention used by Aristotle for this video. Strictly speaking, every syllogism is valid, so an invalid syllogism is no more a true syllogism than a dead dog is a true dog. Nevertheless, loosely speaking, a series of propositions with three terms in one of these three figures can be called a syllogism. Valid syllogisms, then, are syllogisms in which the conclusion necessarily follows from the premises. These are syllogisms simply speaking, or properly speaking. The conclusion necessarily follows from the premises. Invalid syllogisms, however, like dead dogs, are syllogisms in which the conclusion does not necessarily follow from the premises. These are not syllogisms properly speaking, but invalid syllogisms. Now, a sound syllogism is a syllogism that is both valid and has true premises and a true conclusion. So it must be valid, it must have true premises, and the conclusion must be true. That is what we call a sound syllogism. Notice the difference between a valid syllogism and a sound syllogism. For a valid syllogism, it doesn't matter whether or not the premises are true or the conclusion is true. It only matters that the conclusion follows necessarily on the supposition of the premises. Nevertheless, with a sound syllogism, it's not sufficient that the conclusion follows from the premises and the conclusion must also be true. For the purposes of this video, we're going to ignore sound syllogisms and just focus on whether or not syllogisms are valid or invalid. Although the terms in the syllogisms here are depicted with the letters A, B, C, N, M, O, S, P, and R, it is completely arbitrary which letters are used for a given term. You could just as well use X, Y, and Z, or any other three letters. So which letters you use, or in fact which symbols you use to depict the different terms in a syllogism, does not matter. You can just pick anything as long as you're consistent. The important thing is that there are three terms, and these are depicted by some symbol. Now, you must recall from our video on interpretation that there's such a thing called the square of opposition. According to the square of opposition, there are four kinds of propositions. There's the A proposition, which is the universal affirmative proposition, the E proposition, which is the universal negative proposition, the I proposition, which is the particular affirmative proposition, and the O proposition, which is the particular negative proposition. Now, although the letters we use to depict the terms in a proposition are arbitrary, these letters by which we name different kinds of propositions are not arbitrary. So, A propositions are always universal affirmative propositions, E propositions are always universal negative propositions, I propositions are always particular affirmative propositions, and O propositions are always particular negative propositions. These four letters, A, E, I, and O, must be memorized in their relation to different kinds of propositions. So remember that if you see a proposition called an A proposition, that means it's a universal affirmative proposition. And if you see a proposition called an O proposition, that means it's a particular negative proposition. Let's look at some examples. Here are some examples of universal affirmative propositions, also called A propositions. Every Martian is green. All apples are healthy. Notice it doesn't matter whether the proposition is true or false, we're just looking at the form of the proposition. It's a universal proposition, and it's affirmative. We're affirming something of something else universally. Every Martian is green, all apples are healthy. Let's look at some universal negative propositions, or E propositions. Here are some examples. No Martian is green, or not any apple is healthy. In both of these cases, we're negating something universally of something else. So we're negating green universally of Martian. We're saying no Martian is green. We're negating healthy of apple. We're saying that not any apple, not one apple is healthy. So we're negating healthy of apple universally. Here's some examples of particular affirmative propositions, or I propositions. Some Martian is green. Here we're affirming green of a particular Martian, not necessarily of all Martians, but at least of some. Some Martian is green. Here's another example. An apple is healthy. We're affirming particularly of some apple that it's healthy. We're not necessarily saying every apple is healthy, but at least some apple is healthy. Here's some examples of particular negative propositions. Some Martian is not green. Some apple is not healthy. We're negating something of at least one of a subject. We're negating green of at least one Martian. We're negating healthy of at least one apple. Now, I propositions and E propositions are called contradictories. That means if one is true, the other is false. If one is false, the other must be true. Likewise, O and A propositions are also contradictories. If one is true, the other one must be false, and if one is false, the other one must be true. Now, A and E propositions, that is, universal affirmative propositions and universal negative propositions, are not contradictories, but rather contraries. That means they both can be false at the same time, but they can't both be true at the same time. So if one of them is true, the other one must be false. But if one of them is false, the other one might also be false. So memorize these four letters and the kinds of propositions that correspond to each of these letters. That's going to be essential for understanding the rest of this video. Now let's look at the steps to determine if a syllogism is valid. Here we're going to be following not Aristotle's own method, but we're going to be looking at a shortcut to interpret Aristotle's text. Step 1 will be read the paragraph from Aristotle's text. Step 2 will be to translate the paragraph from Aristotle's text into standard notation, and I'll explain what that means later. Step 3, the final step, will be to evaluate the translated syllogism using the Venn diagram method. Let's start with step 1. First of all, let's go over a shortcut to the shortcut. So this whole video is aimed at giving a shortcut to understanding Aristotle's text without having to go through the laborious method that Aristotle himself uses. But there's an even shorter shortcut to understanding Aristotle's text. Let's go over that first, and then we'll go over the longer shortcut. First of all, note that we're using the Loeb edition of Aristotle's Prior Analytics. That's this edition here. Similar shortcuts can be found in most print editions of Aristotle's works, but we'll focus on the Loeb edition. First of all, note what chapter you're reading in the book. Here's a picture from one of the pages in the book. Notice the Roman numeral 4 at the beginning of the paragraph. Notice also the comment in the margin, where it says the first figure. That tells you that everything you find in chapter 4 is going to be a first figure syllogism. So whenever you find a syllogism, valid or invalid, within chapter 4, you know automatically, just because it's in chapter 4, that it's a first figure syllogism. Now look at this picture. Again, we have a Roman numeral and a comment in the margin. This indicates that everything in chapter 5 will be a second figure syllogism. So if you find a syllogism and you look back, figure out what chapter you're in, and you find I'm in chapter 5 because of that Roman numeral 5 at the beginning, you know automatically, just because that syllogism is contained within chapter 5, that it's a second figure syllogism. Finally, notice that with chapter 6 we have the same thing, but now in the margins it says third figure. This indicates that everything in chapter 6 will be a third figure syllogism. So you know automatically, if you find a syllogism in the text and you look to find that you're in chapter 6, you know that that syllogism, valid or invalid, is a third figure syllogism. So in summary, merely by determining if you are in chapter 4, 5, or 6, you can know right away if you're dealing with a first figure syllogism, a second figure syllogism, or a third figure syllogism. So always pay attention to what chapter you're reading. The marginalia help with discovering not only what figure of syllogism you're dealing with, but also if the syllogism is valid or invalid. Let's look back at chapter 4. Here's a picture from one of the pages in chapter 4. Here we find a syllogism described as follows. Quote, if A is predicated of none of B and B of all of C, it follows that A will apply to no C. Notice the word celerent in the margins. In the margins, we find the name celerent. Whenever you see a funny sounding name like celerent or Dari or Philipton, that name next to the description of the syllogism indicates that what you are seeing described in the paragraph is a valid syllogism. So if you see a funny name in the margins, you know automatically that what it corresponds to in the paragraph is a valid syllogism, not an invalid syllogism. Alternatively, when you find two letters followed by a dash in the margin, that indicates that you have two premises that cannot yield a valid syllogism. Or, in other words, what you have is an invalid syllogism. A syllogism in appearance, but not in reality. An invalid syllogism. Let's look at an example. Notice underneath the word celerent, there's another indication in the margins. This one's corresponding to the paragraph below the paragraph that corresponds to celerent. In the margins, we find the letters A and then E followed by a dash. That tells you that what's in that paragraph next to those letters is an invalid syllogism, something that does not yield a conclusion necessarily. Notice that underneath the description of Celerant, you find a description of a set of premises that do not yield a valid syllogism. This is evident, once again, by the fact that in the margin there are two letters followed by a dash. So whenever you find a funny name in the margins, that tells you that the paragraph it corresponds to contains a valid syllogism. But when you find in the margins two letters followed by a dash, you know that what corresponds to those two letters and a dash is a description of an invalid syllogism. What this means is that even if you have no idea what is being said in the paragraph, if it just looks like nonsense word soup to you, you can still determine if the syllogism described is valid or invalid merely by reading the marginalia. It's that easy. If there's a funny sounding name next to the description, the syllogism is valid. If there are two letters followed by a dash, however, the syllogism is invalid. That's the shortcut to the shortcut. If you look only at the marginalia and the chapter number, you can determine not only if a syllogism is valid or invalid, but also what it looks like, without even reading the paragraph itself. So the shortcut to the shortcut gets even better. Let's look at an example. In our first step, we're going to determine the figure of the syllogism. So again, we've got three figures. The first figure, the second figure, and the third figure. In the first figure, the middle term is subject of the major premise and predicate of the minor premise. In the second figure, the middle term is the predicate of both premises. And in the third figure, the middle term is the subject of both premises. Now, we already saw that figure 1 is contained in Prior Analytics chapter 4. Figure 2 is contained in chapter 5. And figure 3 is contained in chapter 6. So, if you know what chapter you're reading, then you'll know that you're dealing with a first figure syllogism, a second figure syllogism, or a third figure syllogism. So in this case, if we flip back a page or two, we'll discover that the syllogism we're looking at is contained in chapter 4. So it's a first figure syllogism. So we know this much, at least, about the syllogism contained in the paragraph. Namely, it has a middle term that's the subject of one premise and the predicate of the other. The subject of the major premise, the predicate of the minor premise. Now, our second step, once we've determined what figure of syllogism we're dealing with, is to read the marginalia to determine the quality and quantity of the premises and the conclusion, if there is one. So, we'll determine this by looking at the marginalia. Notice that I've circled the word Celerant. So let's look at the word Celerant. Why this funny name for the syllogism in the paragraph? Well, the reason is because of the vowels. Ignore the consonants and focus on the vowels. The first vowel is E, the second vowel is A, and the third is E. Now, remember from the square of opposition that there are four kinds of propositions. There's the A proposition, the E proposition, the I proposition, and the O proposition. These vowels, according to their order, are telling us the following. They're telling us that the major premise is an E proposition. The minor premise is an A proposition. The conclusion that follows necessarily from them through valid syllogism is an E proposition. So just by looking at the vowels contained in the name for the syllogism, we can tell that it goes in the following order. The major premise is an E proposition, the minor premise is an A proposition, and the conclusion is an E proposition. So we know the figure of the syllogism, and we also know the quantity and quality of the premises and conclusion in that syllogism. Let's put this knowledge together into a synthesis. The result is the following syllogism. No B is A, every C is B, Therefore, no C is A. So the syllogism that is named Celerant is this syllogism, namely, no B is A, every C is B, and therefore no C is A. So we've figured out what this syllogism looks like merely by reading the marginalia, paying attention to the vowels in the name in the marginalia, and by looking at what chapter we're reading, namely chapter 4, which contains all of the first figure syllogisms. So congratulations, you figured out the syllogism. Without even reading the paragraph, you have discovered what your syllogism looks like, as well as if it is valid or invalid. You know it's valid because it has a funny name, Celerant. You know it's a first figure syllogism because it's in chapter 4. It has a universal negative major premise, a universal affirmative minor premise, and a universal negative conclusion. And you know all of this from the vowels in the word Celerant. And once again, you know that the syllogism is valid precisely because it has a funny name next to it in the margins, namely Celerant. Let's look at another example. Now let's go beneath Celerant to the next paragraph where we find in the marginalia AE dash. Now, once again, we're reading something from chapter 4, and so we know we're dealing with a first figure syllogism. That already tells us quite a bit about what this syllogism is going to look like. It's a first figure syllogism with the middle term in the major premise being the subject and in the minor premise being the predicate. Now let's look at the letters AE dash. Here, since we're dealing with an invalid syllogism, we don't have a funny name, but the same principle applies. We have a series of vowels, and those tell us the sort of propositions we're going to be dealing with in the major premise and then the minor premise. So in the major premise, we have an A proposition, and since we're dealing with the first figure, we know that the middle term must be the subject of the major premise, and so this A proposition must be every B is A. It's a universal affirmative proposition with the middle term as our subject term. And now the second proposition is going to be an E proposition because, again, the marginalia tells us AE dash. So the second proposition, the minor proposition, is going to be an E proposition. That is a universal negative proposition. And since, again, we're dealing with the first figure, where in the minor proposition, the middle term is the predicate, we know that the minor proposition here is going to be no C is B. And then the dash indicates that no conclusion follows. It's not a valid syllogism, and so there's no necessary conclusion. And that's symbolized by the dash. So here, what we have in the marginalia is an indication that what this paragraph is describing is an apparent or invalid syllogism in which we have the first figure and we have a major proposition that's an A and a minor proposition that's an E, and then no valid conclusion. Once again, congratulations. Without even reading the paragraph, you have discovered what your syllogism looks like, as well as if it is valid or invalid. You know that first figure syllogisms with a universal affirmative major premise and a universal negative minor premise are invalid. No conclusion follows from them. And you know all of this merely by knowing what chapter you're reading and reading the marginalia. Okay, so that's enough of the shortcut of the shortcut. Now let's look at the mere shortcut. After all, on a test, you're not going to know where in the book an example syllogism is coming from. So you'll want to be able to figure out if the syllogism is valid or invalid without having to rely on knowing what chapter you're reading or without having to rely on reading the marginalia. After all, you won't necessarily have any marginalia to read. So you'll want another way of figuring out if a syllogism is valid or invalid. Even so, we have a shortcut that doesn't require going through the laborious method used by Aristotle himself. Let's suppose you want to actually understand what's going on in the paragraph itself, and you don't want to rely on the notes in the margin or on knowing what chapter you're reading. Let's focus on the section I've circled here. First, read the description of the syllogism. Here, the description reads as follows. If A is predicated of none of B and B of all of C, it follows that A will apply to no C. Second, translate each part of the syllogism one part at a time. Let's take the first part. If A is predicated of none of B, this is translated into standard notation as no B is A. Notice how I've reversed the order of predicate and subject. Aristotle always writes the predicate first and the subject last, but in standard notation, or in ordinary English conversation, we put the subject first and the predicate last. Let's look at the second part. And B of all of C. Here we have every C is B in standard notation. Finally, the conclusion is this. It follows that A will apply to no C. In standard notation, this reads, therefore no C is A. Notice that when describing propositions, Aristotle always puts the predicate term before the subject term. So, for instance, A will apply to no C is translated as no C is A, not as no A is C. So now we have our syllogism. No B is A, every C is B, therefore no C is A. Now let's evaluate this syllogism. And to evaluate this syllogism, we're going to be using what's called the Venn diagram method. So draw 3 circles all overlapping with one another. Now label each of the circles corresponding to one of the 3 terms in the syllogism. It doesn't matter the order in which you label the circles, as long as you do label them and know what each circle stands for. So here we have the circle on the left standing for B, the circle on the right standing for C, and the circle on top standing for A. We could have put them in a different order. Okay, so now take your major premise and destroy the parts of this diagram which do not correspond to that premise. So we're going to be destroying the parts of the diagram that are falsified by this premise. So since the premise is no B is A, we want to destroy the part where the circle B overlaps with the circle A. So we're basically scratching it out, saying that doesn't actually exist. Next, let's look at the second premise. The second premise is every C is B. So let's destroy the part of the diagram that is falsified by this premise. So every C is B implies that all of the C circle should be inside of the B circle. So let's scratch out all the parts of the C circle which are outside of the B circle. We're indicating thereby that these parts don't actually exist. Now ask yourself, does anything follow from these 2 premises? The answer is yes. None of the C circle that once overlapped with A exists any longer. Therefore, from our 2 premises, it necessarily follows that no C is A. None of the C circle that once overlapped with A exists any longer, therefore no C is A. So a conclusion does necessarily follow, and we've thereby proved that the syllogism is valid from the fact that the conclusion is already true merely by us filling in the parts of the circle that are asserted by the 2 premises. Now let's look at an example of an invalid syllogism. Let's figure out the mere shortcut version of proving that an invalid syllogism is in fact invalid. First, read the description of the syllogism. Here it reads, if the first term applies to all of the middle, in the middle to none of the last, the extremes cannot admit of a syllogism. Next, translate each part of the syllogism. Let's start with the first part. if the first term applies to all the middle. Now here we might seem to have a problem. It says first term and middle. It doesn't have any letters. Remember that what letters we use to stand for the terms in a syllogism is totally arbitrary. So I will just use x, y, and z, letting x stand for the first term, y for the middle term, and z for the last term. I've just picked these letters at random. You could pick whatever you want as long as you're consistent. So standard notation version of if the first term applies to all the middle will be every y is x. Of course, all is the same thing as every, so I could also say all y is x, but I've chosen every y is x in order to be consistent with the diagram earlier, but I could also say all y is x, and that means the same thing. Now the next part of the syllogism is and the middle to none of the last. So we want our middle term to apply to none of the last term. So we'll say no z is y. Finally, we have the conclusion. The extremes cannot admit of a syllogism. In other words, Aristotle is saying there's no conclusion that follows necessarily. This is an invalid syllogism composed of these premises. So again, let's set up our three circles, our Venn diagram. We have two premises. Every y is x and no z is y. Let's first illustrate our first premise. Every y is x. So let's destroy all in the y circle that is outside of the x circle, thereby making the entirety of the y circle contained within the x circle. Next, let's illustrate our second premise. No z is y. We're going to destroy all of the z circle that overlaps with the y circle. We're thereby saying that none of the z circle is overlapping with the y circle because we've destroyed the parts that do overlap, saying these are not fitting with the premise. So we've destroyed everything in the z circle that overlaps with the y circle so that now all of the z circle is outside of the y circle, and all of the y circle is outside of the z circle. Now ask yourself, does anything follow necessarily from these two premises concerning x and z? So remember, our conclusion is going to be about the two terms which have not yet appeared twice. So our middle term, y, has appeared twice, and that's how we know it's the middle term. So we're looking for any conclusion concerning the terms that have only appeared once. Is there any conclusion that follows concerning x and z? Those are the two terms that have only appeared once so far. And the answer to that question is that the syllogism is invalid. Nothing does necessarily follow. From just these premises, we can't draw a conclusion concerning x and z. Now, how do we know that that's the case? The reason we know that's the case is because the two premises fail to rule out either of two contradictory propositions concerning x and z. We could either say every x is z, or we could say some x is not z, and both of these are consistent with the two premises. Let's see how that is. So here I've illustrated one possible conclusion. Every x is z. To illustrate this, I've destroyed the part of the x circle that is outside of z, thereby making all of the x circle contained within the z circle. So that's one possible conclusion that's consistent with our two premises. But here's another possible conclusion that's also consistent with our premises. Some x is not z. This is the contradictory opposite of the other conclusion which we just used. So let's remove our illustration of the last possible conclusion and put in an illustration of the present possible conclusion, namely some x is not z. Since this is a particular proposition, specifically it's a particular negative proposition, we're just going to draw a star symbolizing at least one thing which meets this proposition. So we're going to draw a star within the x circle and outside of the z circle. And this illustrates some x, that is at least one x, which is not a z. The star is a representative of that one individual that is not a z but is an x. So notice that this contradicts every x is z. So if every x is z is true, this star could not exist. And so we see that these two premises, every y is x and no z is y, are consistent with contradictory conclusions concerning the relationship between x and z, and therefore no conclusion necessarily follows, since everything is still open. All options are still on the table, no conclusion follows, therefore it's an invalid syllogism. Because recall, a valid syllogism is a syllogism, properly speaking, one in which the conclusion necessarily follows from the premises. But nothing necessarily follows here, and so there's no valid conclusion, or no valid syllogism. Since two contradictory conclusions are both consistent with the same two premises, those premises fail to yield a valid syllogism. Any apparent syllogism composed of such premises would be invalid. Let's look at another example, this time of a third figure syllogism in chapter 6. Specifically, we'll look at the syllogism called Boccardo. Here's a picture of the syllogism in the text. It reads, if R applies to all S and P does not apply to some S, it necessarily follows that P does not apply to some R. Now, we know from the shortcut of the shortcut that this is going to be a valid syllogism because we have a funny name in the marginalia. We also know it's a third figure syllogism because it's in chapter 6. But here we're not using the shortcut of the shortcut, we're just using the shortcut. So let's actually prove that this is a valid syllogism. Our second step after reading the syllogism is going to be to translate it into ordinary or standard notation. Now, the first part of it, if R applies to all S, can be translated as an A proposition. Every S is R. The second part, and the middle to none of the last, can be translated as an O proposition. Some S is not P. Finally, the last part, it necessarily follows that P does not apply to some R, can be translated as another O proposition. Some R is not P. This is our conclusion. Now, you may wonder why this syllogism is called Boccardo, since the order of the vowels in that name are O, A, O, but the order of the premises given by Aristotle are A, O, O, not O, A, O. Here, recall that the order of premises does not affect the validity of a syllogism, but when syllogisms are named, they are named in a particular order, with the vowel corresponding to the major premise coming first, and the vowel corresponding to the minor premise coming second. But the major premise is the premise containing the predicate term from the conclusion. So in the conclusion here, the predicate is P. In this case, the major premise is some S is not P, since P is the predicate in the conclusion, and the premise some S is not P is the premise that contains the letter P. Thus, the name for this syllogism has vowels in the order O, A, O, Boccardo, not A, O, O. Nevertheless, in the paragraph where Aristotle explains the syllogism Boccardo, he just happens to put the minor premise before the major premise, even though the name for this syllogism puts the major premise before the minor premise, as per the convention for naming syllogisms. So just be aware of what's the major premise and what's the minor premise. They don't always line up with what comes first and what comes second in the paragraph. though they do always line up with what comes first and what comes second in the name, if the syllogism has a name. Okay, so here's our syllogism. Some S is not P, that's an O proposition. Every S is R, that's an A proposition. And then our conclusion, therefore, some R is not P, and that's an O proposition. Once again, let's put together our three-circle Venn diagram. And let's label the circles according to the three terms in our syllogism, P, S, and R. Now, you want to be careful with any syllogism that contains a particular proposition in one of its premises. So, our major premise is an O proposition, but O propositions are particular negative propositions. And so you don't want to illustrate particular propositions first, rather you want to illustrate the universal propositions first. So let's ignore the major premise for now and move on to the minor premise, since that's a universal affirmative proposition. And we want to illustrate our universal propositions before our particular propositions if we have both in our syllogism. So let's illustrate our minor proposition. We're going to be illustrating every S is R. So in order to illustrate this, I've destroyed all of the S circle that's outside of the R circle. Thus, the remaining part of the S circle is entirely contained within the R circle. This illustrates every S, or all S, is R. Next, I want to illustrate my major proposition, our major premise, which is some S is not P. So since this is a particular proposition, I'm going to illustrate it again with a star and not by scratching something out. So I'm going to put a star in a spot that will illustrate that some S, that is at least one S, is not P. There's at least one thing in the S circle that's outside of the P circle. And so I have two options. I could put the star inside of the S circle where it overlaps with the P circle, or inside of the S circle where it's outside of the P circle. I want to put it in the part of the S circle that's outside of the P circle in order to illustrate that some S is not a P. So if I put it in the other part that remains of the S circle, I wouldn't have illustrated that some S is not a P. So I want to put a little star in the S circle but outside of the P circle in order to illustrate some S is not P. Now ask yourself, does anything follow from these two premises concerning R and P? So again, we want to focus on R and P, and that's because these are the two terms that have only appeared once so far in our premises. So the middle term is the term that appears twice in the premises. The major and minor term, however, only appear once in the premises. Yet these are the ones that will appear in our conclusion, and so to see if a conclusion follows necessarily from our premises, we want to focus on the two terms that have only appeared once so far, namely the minor term and the major term. In this case, they are R and P. So let's see if anything necessarily follows from what we've drawn concerning R and P. The answer is yes. Already from the two premises, we know that there are some R that are outside of the P circle. Thus, the syllogism is valid. So how do we know that there's something in the R circle that's outside the P circle? Well, we know because we have that star which is in the S circle but outside of the P circle. And because all of the S circle is contained in the R circle at this point, since we destroyed the rest of it. And therefore that star that we put in the S circle but outside the P circle is also in the R circle. And so there is some star, that is some individual in the R circle that's also outside of the P circle. And that, in fact, is our conclusion. Some R is not P, an O proposition. So we've already had that proposition illustrated merely by illustrating the premises without illustrating the conclusion. And that tells us that the conclusion follows necessarily from the premises. So we have a valid syllogism, because a valid syllogism is a syllogism in which something necessarily follows from the premises. Notice in the three examples I've gone over of the shortcut for reading Aristotle, in no case do I illustrate the conclusion as a positive action. Rather, the only thing that I illustrate are the premises, and then I see whether any conclusion has already been drawn by the illustration of the premises. So with this video, you've seen the tools for both understanding Aristotle's text without reading the text itself, just looking at the marginalia, as well as the tools for understanding the text intrinsically without being able to rely on the marginalia or knowing what chapter you're reading. So, in other words, we've gone over two ways of understanding Aristotle's text. In one way, you have to know what chapter you're reading, and you have to be able to read the marginalia. That's the easiest way to understand Aristotle's text. But there's another way, which is also easy to understand Aristotle's text, in which you don't have to rely on marginalia, and you don't have to rely on knowing what chapter you're reading. You just read the text itself, and you'll know what it means. This method follows two steps. First, you read the paragraph. Next, you break it down into standard notation through translation. And then finally, you evaluate it using the Venn diagram method.
Господня Пасха, о смерти, о жизни,